Example 10. Find the minimum point and the maximum point of the curve y equal to 3x to the power 4 minus 4x cubed. Okay, for this question, the question didn't mention using the first or second derivative test, so we can choose either using the first or second derivative test. Okay. So first of all, to solve this question, the same thing, we have to find the stationary point. Okay, given this function y equal to 3x to the power 4 minus 4x cubed. Okay, so we have to differentiate it. We will get our dy dx is equal to 12x cubed minus 12x squared. Okay, so as we know, stationary point is dy dx equal to 0. So we make our dy dx equal to 0. You will get 12x cubed minus 12x squared is equal to 0. So now we try to simplify. Okay. To get the answer for x, we try to factorize out 12x squared. We will left x minus 1. After factorize, equal to 0. So our first x you will get equal to 0. The second you will get x equal to 1. Okay, so after we get the x, we will get the y, value for y. So the same thing, when x equal to 0, you substitute x equal to 0 into your function of the curve, you will get y equal to 0 also. When x equal to 1, you will get y equal to negative 1. So means that the stationary point are 0, 0 and 1, negative 1. Now we are using the second derivative test to test the two stationary points. Okay, so first of all, we have to find the second derivative function. You will get our d2y dx squared is equal to 36x squared minus 24x. Okay, so this is the result of the second derivative test. Now we come to the first point. For point 0, 0, the d2y dx squared is equal to 36 multiplied by 0 square minus 24, 0. So you get the answer equal to 0. If you get the second derivative test equal to 0, means that we cannot decide is a maximum or minimum. It means the test failed, and we have to switch to the first derivative test. So we have to come back to the first derivative test. For 0, 0, so the same thing, we have to draw the table if you want to use the first derivative test. Okay, we test for 0. You choose a value before 0 to substitute into our dy dx. So maybe we can choose negative 0.5. Okay, so when we substitute into the dy dx, you will get negative. Okay, means that we substitute negative 0.5 into our dy dx. Okay, when we substitute 0 into our dy dx, we will get 0. When we substitute 0.5, you will get positive. Okay, remember, don't substitute the x which is too far from the point that you want to test. Okay, so if negative means the slope is decreased, 0 horizontal, and plus is increasing. So means that 0, 0 is a minimum point. Okay, for this point, the second derivative test is failed, so we have to switch back to first derivative test. Now we come to the point 1, negative 1. I will use the second derivative test to test for this point. So after I substitute x 1 equal to 1 into my d2y dx square, I will get 36 multiplied by 1 square minus 24 multiplied by 1. So I will get 12, which is greater than 0. So means that is a minimum. From here we can conclude that 1, -1 is a minimum point.